All right, class, in this lesson, you're going to learn to describe how linear factors of a function combine to produce intervals of increase and decrease in the product function and when it is positive and negative. Okay, so let's go ahead and get started with example number 1. So consider the function f of x is equal to negative x plus 3. Okay, you should recognize that that is a linear function. It is a line and it has a negative slope. And if you dilate this function by another function, x, we need to determine the following. Okay, what does the product function look like? What are its zeros? Where is it positive? Where is it negative? Where does it increase? And where does it decrease? All right, so the best way to do this is to go ahead and graph it. I like to use Desmos. So the function is going to be x times negative x plus 3. Okay, and as you can see, this is a parabola. It's a quadratic function that faces down. Okay, so let's go ahead and write that down. Parabola facing down. Okay, now what are its zeros? What this question is asking you is, where does the function cross the x-axis? Okay, so if you take a look, you see that there's a dot at 0, 0 and a dot at 3, 0. And this is telling us that it crosses the x-axis at 0, 0 and 3, 0. Now, this happens to be easy to determine because it crosses at a nice point on the x-axis. However, not all functions cross the x-axis at an obvious point. So the way to figure this out is to take each linear function and set it equal to 0. For example, the first linear function that we have here is negative x plus 3. So we're going to set that equal to 0, and then we're going to set this function equal to 0. All right, so negative x plus 3 is equal to 0, and then the other function was x is equal to 0. Okay, now if we solve for x, we're going to add x to both sides. And when we add those together, these cancel out, and now 3 is equal to x. Okay, for this second equation, there's nothing that needs to be solved because we're told that x is equal to 0. So what we're going to do is say that 3 comma 0, where did this 3 come from? It came from this 3, okay? My y value is always going to be 0 because where it crosses the x-axis, y values are always 0. So one of the zeros is 3 comma 0, and then the other is 0 comma 0, okay? The 0 comes from this 0. And as you can see from what we graphed, it does cross at 0, 0 and also crosses at 3 comma 0. Okay, so let's move on to the next question. Where is it positive? Okay, so if you take a look at the function, it is positive when this function is above the x-axis, and that takes place from x equal to 0 to x equal to 3. So from here to here is where the function is positive. So the way we express it is as a range. Okay, we put open parentheses that tells us that it does not equal 0, but anything to the right of 0 will be correct, and then it goes all the way to 3, and it does not include 3. And then we write in a closed parentheses. Okay, so that's where it's positive. Now the next question is, where is it negative? Well, it's negative from anywhere below the x-axis. Okay, so that's going to occur anywhere from negative infinity of the x value all the way to 0, and then from 0 all the way to positive infinity, right? Because both the left side of the function and the right side of the function are below the x-axis. So we would say then that it is negative from negative infinity, and again, these are ranges for the x values. So from negative infinity to 0, and from 3 to positive infinity is negative. Okay, now where does it increase? Well, it increases, and again, we're looking at x values going from left to right. So as we move from left to right, okay, the function increases from negative infinity all the way to somewhere in between 0 and 3, okay? You see that it peaks at somewhere at probably 3/2, comma, 2.5, perhaps, or 2 1/4, okay? We don't know exactly what that point is, and I'll show you how to figure that out. And then after that point, it continues to decrease, okay? So we need to find that point. And when I say that point, what I'm talking about is in that graph, we want to know where this point is at the very peak. Well, if you take a look, what you can do is we've already found these points here, okay? We already know that this is 0, 0, and this is 3, 0. So we want to find the midpoint between 0 and 3. Well, how do we do that? Well, the midpoint is found by adding those two numbers together. So 0 plus 3, and we're going to divide by 2. And that works out to 3/2. Okay? So that means that the function increases from negative infinity all the way to 3/2. And then it decreases from 3/2 to positive infinity. Okay? All right, so let's move on to the next example. We have two linear functions again. This time we have negative x minus 2, and we're going to dilate that function by negative x minus 1. Okay? Both of those are linear functions. So what does that look like? Let's go ahead and type that in. Negative x minus 2 times negative x minus 1. Okay? So we see that when we have two negative linear functions, so a negative times a negative, when they get multiplied together, becomes a positive, and this is why we now have a parabola that faces up. Okay? So then we would say parabola facing up. And what are its zeros? Well, let's take a look. You could see that it crosses at negative 2, 0 and negative 1, 0. Okay? Now remember, if you can't determine that, we would set each of these functions equal to 0 and solve for the x's. Okay? So we would have negative x minus 2 is equal to 0, and then we also have negative x minus 1 is equal to 0. And if you were to solve for x, we would add x to both sides. And we solve both of these equations. This works out to negative 2 is equal to x, and this one is negative 1 is equal to x. And so my zeros are negative 2, 0 and negative 1, 0, which is consistent with what we saw on the graph. Negative 2, 0 and negative 1, 0. Okay, so those are our zeros. Now where is it positive? Well, it's positive from negative infinity all the way to negative 2 on the x, okay? When x values are negative infinity to negative 2, all my y values are positive, and from negative 1 of my x value all the way to positive infinity, my y values are positive. So we would say that it is positive from negative infinity to negative 2 and from negative 1 to positive infinity. And then where is it negative? Well, it's negative from negative 2 to negative 1. Okay? So in that range, we would see that the function is below the x-axis. So then it is negative from negative 2 to negative 1. And then where does it increase? it increases from this point here, okay? It says negative 1.5. So when we move to the right, as x increases, the function also increases, and then it decreases from negative infinity all the way to negative 1.5, okay? So to find that inflection point again, so let me go ahead and graph this. Okay, so let's say we have this function here, right? And we had this line, okay? And we want to know what is the midpoint between this dot here and this dot here. And we know that this coordinate is negative 2, 0. And this is negative 1, 0. So we would find the midpoint by adding negative 2 and negative 1, and we divide that by 2. Okay? And that works out to negative 3/2. So where does it increase? It increases from negative 3/2 on the x all the way to positive infinity. And then where does it decrease? It decreases from negative infinity on the x all the way to negative 3/2. Okay? Remember, we always read from left to right. Okay, hopefully that made sense. If any of this was confusing, go back to the beginning of the recording and listen to it again. Thank you.